Okay, number 10, we have some limits. All right, let's look at the first one, A. The limit as x goes to infinity of x over e to the x. Okay, so if we examine both the numerator and denominator, we see that as x goes to infinity, the numerator goes to infinity, and the denominator as well. E to the x keeps growing as x gets larger. All right, so we have what we call an indeterminate form. That is something, a limit, which we say is the indeterminate form infinity over infinity. And for such a limit, we can use L'Hopital's rule. Which says that if we have an indeterminate form, that is a limit of the form infinity over infinity or 0 over 0, either one. That's another indeterminate form. Then this limit is equal to the limit of the derivative of the top divided by the derivative of the denominator. Okay, so that's L'Hopital's rule. All right, and once we do that, we have 1 over e to the x. The derivative of e to the x is e to the x. This is no longer an indeterminate form. Now the denominator, as x goes to infinity, the denominator is going to infinity. The numerator, of course, stays at 1. So this entire quotient is going to 1 over infinity, or 1 over something that's growing larger and larger, and that limit is 0. Okay. Next, we're going to look at the limit as x goes to infinity of 1 over x times log x. So as x goes to infinity, 1 over x goes to 0, since the denominator is growing and the numerator is staying the same. 1 over x goes to 0. And ln x goes to infinity. So we have 0 times infinity. Just rewrite this. If we rewrite this, we will get, just put the x in the denominator. And then we have an indeterminate form. We have a limit where the numerator is going to infinity and the denominator is going to infinity. So when we have an indeterminate form, such as infinity over infinity, we could use L'Hopital's rule. I'll just abbreviate it with an L apostrophe H. L'Hopital's rule tells us that the limit is equal to the limit as x goes to infinity of the derivative of ln x divided by the derivative of x. So now when x goes to infinity, this numerator is going to 0. 1 over x goes to 0. Okay, so the limit is in fact 0. Okay, C is a little bit different. In C, we have a base with containing some x expression, and we have an exponent that's also contains x. Okay, so we have x in the exponent and x in the base of this exponential expression. And the way we evaluate this limit is first we evaluate the limit of the log of this expression in order to bring down the x. So that's a standard trick when we're in this situation. X in the base and x in an exponent of some sort of exponential expression. So let's say what we want to do is let's get another variable like y, and we'll put y equal to 1 plus 1 over x to the exponent x. So log y is equal to x. We'll bring the x down right away using our log rules. X times log 1 plus 1 over x. So what we're going to do is we're going to take the limit as x goes to infinity of log y rather than y. All right, so let's do that. So we have the limit as x goes to infinity of log y Okay, that's the limit as x goes to infinity of this expression. Now I'd like to write this expression in with the putting x in the denominator as 1 over x, and that'll give me an indeterminate form so that I can use L'Hopital's rule. So we'll see why in a second, why that works. This is, again, a standard trick. Because what we do have here, when x goes to infinity, this is going to infinity. This is going to 1 plus 0. So this is going to log 1, which is 0. So we have a infinity times 0, which can always be changed into an indeterminate form by putting something in the denominator. So that's what we did over here. So now, so we changed this. This was an infinity times 0 limit. Okay, again, it could always be changed to a 0 over 0 by putting this in the denominator, taking the reciprocal and putting it in the denominator. Then we get a 0 over 0 limit. So that's what we did there. All right, now the numerator is going to 0 like before, and now the denominator is also going to 0. So now we have another indeterminate form, the 0 over 0 indeterminate form. So again, we can use L'Hopital. All right, so that's just the justification of the next step, which is taking the derivative of the top and bottom of the numerator and denominator. Here we get minus for the denominator 1 over x squared. Okay, the numerator is going to be a little complicated. It's 1 over 1 plus 1 over x in the denominator times the derivative of 1 over x. I'm going to squeeze into the numerator over here, minus 1 over x squared. And these cancel. This denominator with this numerator cancels. Okay, so that simplifies quite a bit. Okay, and there we have the limit as x goes to infinity. Okay, we're going to cancel this and this, and so we get 1 over 1 plus 1 over x. And what's that equal to? Well, as x goes to infinity, this goes to 0. So the limit is 1. But we're not quite finished, because what did we see? We saw that this is the limit as x goes to infinity of ln y. So in other words, ln y goes to 1. To see what y goes to, we just do the inverse of ln, the exponent. We exponentiate both sides. So e to the ln y is y. So y goes to e to the 1. So we're exponentiating both sides. So this is e to the ln y, that's just y, and this is e to the 1 right there. So that's our limit. Our limit is e to the 1, or e.